To safeguard the future of the Port of Antwerp, sufficient draft is essential for shipping traffic. Consequently, the Antwerp Port Authority deposits large volumes of silt every year. However, the Port Authority is running out of deposit areas. Therefore, the processing and storage has to be tackled in a new and lasting way by building a silt dewatering plant in the port area. Amoras was the name given to the project. Two of the world's largest dredging companies combined powers and proposed to design and operate the silt dewatering plant for the Amoras project. Supported by their environmental subsidiaries, having the necessary environmental expertise, they established the joint venture Seriant. This film demonstrates how the dredged material passes through the underwater cell to the deposit area. Simultaneously, we explain why Seriant can guarantee the most durable, reliable, and user-friendly solution. The dredging department of the Port Authority dredges the silt and stores it temporarily in the yet-to-be-built underwater cell in the canal dock. The more contaminated dredged material is not temporarily stored underwater, but is pumped directly ashore to the treatment plant using a barge unloading dredger. On the wharf nearby the underwater cell, a sand separation plant with a series of hydrocyclones is being built. The plant makes it possible to simply choose whether to desand the material or not through an ingenious system of movable sieves for separation and refinement. This concept decreases the number of pumping steps and simplifies the discharge pipelines, the valves, and the controls necessary to potentially bypass the sand separation. The sieved silt is dropped in a rehandle tank, from where it is pumped to the treatment plant 4 kilometers away by means of booster pumps. Conveyor belts transport the sand out of the plant. The compact build of the sand separation plant has the additional advantage of leaving sufficient space available for the storage of the separated sand awaiting a new destination. The dredged material, whether desanded or not, is pumped through a discharge pipeline to the treatment plant, Bietenveld. The pipe diameter has been chosen so as to be able to pump the dredged material at low power. When choosing materials, solidity and low maintenance were highly valued assets. Once at Bietenveld, the dredged material is deposited in one of the 4 consolidation ponds of 115,000 square meters each. Thanks to an innovative dredging system with a rotating gantry spanning the consolidation ponds, the dredging process is controlled completely automatically, independent of the amount of water on top of the sludge. This results in higher precision. The dredging gantry is equipped with 2 dredge pumps, which can be moved along the whole span and which can operate independently. This guarantees a larger operational safety and higher pumping production. It also makes it possible to redistribute the material within one compartment or in between several compartments. That way, the filter presses can be fed with an almost constant mixture density. Engineering office Laurent Ney and partners took care of the architectural aspect of the dredging gantry. In the dewatering hall, the condensed dredged material is conditioned and then dewatered into filter cakes. 12 membrane chamber filter presses dewater the material by expressing water under pressure with a filter cloth. To make a continuous and controlled feeding of all presses possible, one central buffer is connected to all presses. Thanks to a well-considered placement of the filter presses, the filter cakes arrive on 3 slowly turning conveyor belts. These conveyor belts lead to one of the 2 transport belts that bring the filter cakes to the deposit area. The plant has been designed with the option to expand. Thanks to the many years of experience with mechanical dewatering and the choice for extremely solid equipment, Seriant stands for a state-of-the-art installation. The location and the choice of filter presses and the auxiliary equipment is aimed at low maintenance and safety for its operators. Redundant execution of critical parts guarantees maximal production even with a mechanical failure. The filtrate water originating from the membrane chamber filter presses will be treated together with all other wastewater flows in a suspended active silt system. This can be seen as a variant on the moving bed bioreactor. The goal is to maximally reuse the cleaned wastewater as process water and only discharge the surplus water in accordance with the prevailing standards. The produced filter cakes are stored on the Zandvinningsput site. The goal is to stack 50 meters of filter cakes on top of 10 meters of moderately consolidated silt that was already deposited in the Zandvinningsput site. The phasing of these storage works is derived from the stability study of Professor Jan Martens. To prevent the filter cakes from sinking into the underlying silt, they are placed on top of a geotextile according to a strict phasing. This methodology offers the best guarantee to work safely without risk of sliding away. The installation of vertical drains in the underlying sludge prior to the sealing of these layers results in an accelerated consolidation process and a higher stability safety factor during construction. Moreover, this approach guarantees a maximal exploitation period for the project. Irrespective of possible recycling options of the filter cakes in the future, this deposit area can be used during 25 years at a rate of 500,000 tons per year. Durability, operational safety and user-friendliness are the cornerstones on which our design is based. The installations meet the current ecological standards in which we strive for a maximal return of the used energy in every phase of the process. Our far-reaching automation results in thorough control and a precise functioning. Moreover, special attention went to the maintenance aspect with the choice of materials, the material itself, and the placing of the installations. A calculated approach for the storage of the filter cakes offers sufficient safety guarantees and the available capacity is optimally used. The expertise present within Seriant acts as a guarantor for an elaboration of the Amoras project, which corresponds to the ambitions of the Flemish government and the Antwerp Port Authority.